Here we are today. The talk is YAY-PIs. It's a contraction of APIs and yay! The focus is going to be working on Python to consume REST APIs. And we're going to go over what all that means, why we might want to do it, what sorts of things we can do with it. But I wanted to start with this little preamble, why it's important to have fun. I think my path to what I'm doing here, where I work now, what I do on a day-to-day basis, is very indirect. I am not a computer science major. I'm not any kind of IT student. I was an art student. I worked in education for a lot of years, and I think as a result of being an artist and working in education, that became my into using Macs. And so my approach to doing this was never like a formal computer science education, and I have the kind of work ethic and the philosophy of a studio artist rather than perhaps an engineer. I am an engineer now, I guess, so I guess those things are fighting the eternal battle. But what I wanted to talk about, this why it's important to have fun subject, is that one thing that we see all the time when I was teaching art students, for example, is that it's really easy to get into this situation where you're like, I can see this thing that I want to make, and it's way outside my capacity at this time, and I can think about some of the decisions, but I really can't figure out how to architect this thing, make this thing, draw this thing, and you get crippled by this size of this giant thing that you don't know how to approach it. Instead, the approach usually needs to be that you just go into your studio and you work. And it might be on something that you throw away, something that's useless, something that's silly, something that you don't want to show anybody ever because it's super embarrassing. You need to keep making progress on these things. You need to keep doing it and experimenting and playing and learning new things and trying stuff out that you don't have any intention of using, that doesn't have any bearing on your job whatsoever, because otherwise you're not developing your skills. And so I did it the wrong way when I started doing this. One of my first projects was I really needed something that was going to allow me to get data out of the Casper API. And had to make a lot of U-turns to go do some little silly projects and understand the language better, understand the architecture of these things a lot better. So what we're going to look at today is a lot of fun projects. There's a couple serious things that can actually be helpful for Mac administration inside, but mostly we're going to look at silly projects to understand step by step the kinds of things that we can do with REST APIs. I jumped in the wrong direction there. This is an experiment. I'm using Git Pitch. Has anybody seen Git Pitch before? It allows you to write your presentation entirely in Markdown and post it to GitHub as a repository, and then it gets slurped in and processed into a presentation. So it's going to let me do all the code presenting and fancy stuff like that. And it's pretty cool. So we'll see if it works. It's scary to deviate from Keynote. Anyway, I want to throw up just a few things. These are some libraries that I come to all the time when I'm trying to just fool around. Like I said, my background is in film and visual art. And so I make heavy use of Pillow. Pillow is a fork of the Python imaging library, which doesn't seem to really be maintained that much anymore, if at all. So Pillow seems to be a little more alive. And I put a second item on there. It says more image processing. Scikit image does a lot of the same things. But these are Python packages that make it super easy to open images, any format, save images, sharpen images, change the color balance, perform all those operations that you might be used to doing in Photoshop. It can resize things, it can cut and paste things, it can composite things. So it's the toolkit for a lot of foolishness that I get through. Likewise, OpenCV is a pretty amazing library. I think I looked the other night and they said they have something like 15 or 1,800 algorithms implemented for this, for machine learning and computer vision stuff. So it makes it super easy. It has Python bindings. So you can do pretty amazing things like tracking images in videos, or tracking objects that are moving around. You can do facial recognition. You can do all kinds of identification stuff with that. I'm actually going to show some later, but I'm cheating and I'm using a different library. But OpenCV is kind of the gold standard for that. For data visualizations, I put up Bokeh, not because it's the only one or it's the best one, it's just the one that I'm using right now for little fun projects. We're doing like a Mac health dashboard internally, and we're using Bokeh for all our graphs. So it's really cool. It's, you know, Python, but the display is actually JavaScript, so it's interactive graphs. Lets you interact, change the sliders, and do queries and things. So it's pretty slick. And then the final thing I wanted to mention, and I don't think I use it in the presentation, is nltk.org. So it's the Natural Language Toolkit. It allows you to take English language text and parse it into a parse tree, just like we're going to be doing later with XML or JSON, and interacting with it programmatically. So we can extract things like, what are all the adjectives in here, or what is the structure of this document? We can do some mad scientist, mad lib things where we're replacing all the nouns, or, you know, stuff like that. And I just want to throw this up quickly. Again, my background is in art, so I'm always interested in like curated art. So it's super easy, and it's also important for you to have projects on your GitHub, share them on Twitter or whatever the kids are using these days, and get these projects out, even though, you know, they may be useless. But there are curated places that do new media art, which I'm told I'm like in grandpa zone because it's not even new media art anymore because it's just art. So I feel super old. But anyway, these are also great sites to go see what people who are actively working, who view themselves as artists, are producing. So not just like silly projects, like I don't want to say legitimate, but, you know, practicing artists. There's, looking around, several people I know in here who are already very familiar with this material. And so I challenge you to come up with a ridiculous project. You can Google in the background, find the kinds of libraries you may be interacting with that may do interesting things for you very easily, and throw those in the PSU MacAdmins Slack. I'd love to go back and see what kind of silly ideas people come up with. Just an example, and we do some of this. You can grab a query from Twitter and get all the tweets about tacos. Then we're going to use Natural Language Toolkit, which we talked about a second ago, to tokenize the text, and then it has a tag method that allows you to identify parts of speech, and you can get all the adjectives out. I would want to see visually how people are describing tacos. I love tacos. I don't know if that's apparent yet, but it will be very soon. So I've talked all over and over again about how I'm an artist. Strangely enough, I'm also in this ridiculous meathead sport of weightlifting. This is not the one where you flex your muscles and get spray tans. It's the snatch and the clean and jerk. It's an Olympic sport. It's strange and beautiful. But the reason I bring this up is that I coach weightlifters as well. And it's super overwhelming to have somebody come in and expect them to take a weight from the ground and lift it overhead where it could potentially crush them, and say to them, okay, I need you to move your feet out about 3 inches and turn your feet out about 15 degrees, and you need to externally rotate your hips further by using your adductors, and your thoracic spine's non-extension, your chin needs to come down, shoulders are too in front of the bar. They're going to freak out. So we have this concept in coaching, I'm sure everyone's familiar with it, of triage, where you identify one thing that is the critical thing that they need to fix, and you focus on that. You don't talk about anything else. Really junior coaches will try to tell you everything because they're very enthusiastic, and I'm trying to not be like that in this presentation. There's lots to talk about, and I want to try and keep it simple and focus on one concept at a time, build up over the course of this. It may seem slow at times, but it's to keep the focus on the item at hand. Like I said, this project includes all the example code. So when we look at code, we're going to look at just pieces of the code. And that's one of the cool things that GitPitch does. This allows it to do code presenting. So if you're like, what? I don't even understand what's happening there. Take a look at the source code, and you can see the whole file. But we'll generally be looking at 1 or 2 things at a time. So an example of that, I'm getting scroll bars on this. That's new and unfortunate. Sorry. So the very first thing I want to point out on our very first example is that I've got this shebang line. We're using Python 3. I'm using Python 3 for basically everything at work. I'm using Python 3 for basically everything for fun. obviously there are things that you can't get away with Python 3 because it's not included by default, so brand new machines don't have it, but that's one of the very first things I install on machines. So obviously I haven't ported Monkey to Python 3 or anything like that. But so for the example, we're going to port requests. Since we're going ahead and installing a third-party version of Python, if we can call it that, I'm also not going to be afraid to use requests, which is going to be our very simple way of making HTTP requests, which is most of what we're doing today. And I'm also getting that Python image library. My highlighting's a little off here, and it's super dark up there. Well, maybe we can dim the lights a little bit. But you can see the highlighted part. Request makes it super easy. I'm missing the line apparently where it actually does the request, so it kind of defeats the purpose of the example. But the syntax is super simple, and it makes it really easy to get our data out. We're hitting Giphy for a single taco query. So you tell requests you want to go to this URL, get the data back for me, and it's going to return a JSON response to you, which we turn into native Python data. This is structured. It's a series of dictionaries nested within each other. And so we look inside. I want to get one of these taco GIFs. And I hope nobody's super offended at my pronunciation of that. We can have words later about that. But drilling down, we have a data list. And within that, there is a number of images. And I'm just going to pull out one, which is the original. I'm happy to just take whoever uploaded this in the first place and show it. So we have to provide this lengthy string of accesses to the dictionaries nested within each other. And then I've kind of hand-waved around downloading the actual image itself from that URL and displaying it. And we use the Python image library to display the image. This is just a basic query. And we'll go through these step by step as we move forward. This is not a taco. Just keep that in mind. For all these projects, we're going to go through kind of the same process to set them up. And I just bring it up because it's kind of a best practice for this sort of thing. So if you look at the bottom, the link is to the Hitchhiker's Guide to Python. There's a lot of stuff in there that is pretty good about promoting best practices in Python programming that I've been doing Python for what seems like a really long time now, and definitely learned a lot out of that. So take a look at that. It's a living document. It changes all the time. But for all of these, we're going to use Python 3. We're going to make sure we have the certify package installed, which is made super easy by that package installer. There's other ways to get Python 3, and you can read all about how to install Python 3 different ways and install certify if you need to. But in any of these projects, once we're in the project folder, I've created a virtual environment for all of these. It's not in the GitHub repo. You would have to create your own, and you just do it by running, among other ways, Python 3-m for module, virtual env, venv, and the name of the folder you want to create. And then you source it. And what this does is it links into that virtual environment folder you created, your Python interpreter, your Python packaging tool, everything else. So you have essentially your own copy of that within. And then you can install the requirements for it with the last line, pip3 install. I put the pip3, the 3 is not really necessary, but it's just to highlight the fact that we're using Python 3 so we don't forget their alias to the same thing. But pip3 install -r requirements.txt grabs all the requirements, all the dependencies for any project, and downloads them all. And it puts an individual copy in each project so that it's its own discrete thing. It's not going to step on any other projects that you have. All right, so let's start going through. What is a REST API? And first we're going to talk about what an API is. So I think that's a pretty important part to understanding the abstraction of application programming interfaces. Our ever-present source of definitions, Wikipedia, says that an application programming interface is a set of clearly defined methods of communication between various software components. Okay, great. What does that mean in practice? Well, one of the things that you probably do an awful lot of in Python is manipulate lists. And so we're going to talk about the list API. In our little code example here, we're just going to create an empty list. We're going to add an item to it with the append method of that list object, and then we're going to print it. If we do help on lists within the interpreter, we get helpful information, right? So we learn about how do you create a list. Those are the first couple lines, how to make a new empty list and initialize it. We have an extend method. We have a pop method for removing an item and returning it to the user. We have an append method for adding an object onto the end. This is a design that was created by the software engineers who wrote Python. And what you learn as a consumer of this is how to interact with lists. We are provided with a handful of list methods. Most of these we're probably all familiar with. There's also the list magic methods, which in Python do a variety of things that allow us to use the syntax of Python. So for example, if you have two lists and you add them together with the plus operator, there's a magic method that handles what it actually happens there. When we append a string to our list, we want to add that string into our list. We don't care about how it happens, right? There's a very interesting article at this site that talks about how the list in Python is implemented. And I'm not going to go over it in great detail, but I just want to bring it up as an example of how we don't care how lists are implemented. We don't precisely care how our REST APIs are implemented. We just want to know how to get data out of them. So the list C code for Python, CPython, which is the primary way most people are interacting with Python, has a number of methods, right? PyList append, it calls another function inside. We're skipping through this because we don't need to go over it. But the interesting thing to point out is, thanks, Greg. Yeah. Dark theme. Probably not best for presenting. Oh, I'm okay. Let me know if it gets too spooky. But here's the interesting thing about lists. Lists in Python are a linked list. And what that means is the list itself, the actual data that the list holds, is just a list of pointers to regions in memory that hold the data that we're interested in. When you create a list in Python, that is of size 0. When you add one item, it's size of 1, it has 1 pointer in it, but it actually allocates memory for 3 more slots. And the reason it does this is that it's trying to balance the performance of calling that memory allocation function versus the memory space that it takes up to do so. So once you've added 4 items and you add a 5th item, now it's going to add 4 more. And you can see they give the growth pattern here. It goes from 0 to 4 to 8 to 16, on and on and on. You can see they're pretty crazy bitwise right shift plus ternary operation. If you're super into C, you're like, yes, this is amazing. But graphically, it makes a little more sense. So we add one thing. It takes that first slot. That pointer is in there. We add 4 things. They're all used. If we add one more thing, it needs to allocate more RAM. It's interesting. Who cares, right? You just want to add things to a list and then manipulate them. In our specific instances, we want to talk about Big Trouble in Little China being the best movie ever. I have another example that we don't need to go any detail in, but just to really bludgeon the point to death, here's the BSD style assembler code for how to print that message to the screen. Calling convention is a little different than Linux. I don't know why we need to see that, but just think about it. So an API, we understand that, hopefully. What does it mean to be RESTful? And REST, okay, we're going to define what the acronym stands for. Representational state transfer doesn't mean a whole lot to me. Application programming interface, when I hear that, I'm like, okay, I can kind of infer what that means. Representational state transfer, on the other hand, is kind of a confusing concept. So I think the most important part of this is the representational part. what we're talking about is that the REST API is exposing a representation of something that's on a server. So it could be a file, it could be a concept, it could be a database record, but the representation of that we get back is usually serialized into some form like JSON or XML. It's not the thing itself, it's a representation of the thing. What we are dealing with, these representations, are of unique objects. And so one of the core ideas of this REST architecture is that REST is about exposing resources. Resources are unique and they can be uniquely addressed. So when we look at the URL for an object, the Giphy example that we did earlier, here's the URL to get the actual image itself, and it's going by this ID. They use these crazy IDs that are numeric and alphabetical IDs. But that will only ever point to the same resource. They're guaranteeing that that is a unique resource. The representation of that we get back when we make that web request is in JSON. So JSON is just a way of passing object data around. We already looked at this. We see this dictionary. It tells us what kind of type of item it is. We get a bunch of different images, different sizes. You can drill down through all the data and see what these things are. And that's part of the experimentation process of this, is looking at the data you have and understanding the structure and what kind of data you can get out of it. State transfer is the other part of REST. And it's kind of confusing, and I don't think it's super important for our understanding of practical uses of REST APIs, especially because it seems like in a lot of cases REST APIs or so-called REST APIs don't actually follow the architectural constraints of the REST architecture, meaning they don't have this system of hyperlinks embedded in their responses that allow you to traverse the tree without having any kind of documentation page. Like I said, we don't need to super worry about that. So I think the representational part is the important part. And then a final little caveat that REST is not a protocol. So there's no overseeing body saying, this is the structure of REST APIs, they must be this way. It's an architectural style. So while most people would tell you that the first URL is the, quote, proper way to address an individual item, catalog item number 1729, the second one is also valid. It also means that in a lot of cases we don't necessarily see all the HTTP methods implemented. There's some more arcane HTTP methods that you maybe don't see too often, like patch and options, which we'll kind of not even have to talk about today, but there's no requirement that they be implemented. So that's great. That's all kind of the philosophy behind it and understanding what a REST API may be. But really, we want to know practically how can we code working with REST APIs. I have this exciting graphic of some modern computing devices. And to a certain extent, this actually represents that state transfer concept too a little bit. But every request from a client to a server goes in this circular pattern. So you make a request, you get a response. You make another request, you get a response back. Those requests and responses are structured in certain ways. Different parts of the request and different parts of the response are going to determine the success or failure, what's contained in the response. And so we need to know how to create those requests and how to deal with the responses that we get back. So requests are made by the client, and they're composed primarily of a few things. The URL, and that determines which resource we want to work on. The HTTP method determines which action to take. And so this is to do something like, I want some data, I want to delete some data, I want to update some data. The headers configure a variety of things. Things like authentication can be in there, requested return type. This can be very dependent on the API in question. And so it's one of these things where we have to read the documentation to figure out what kinds of things go in there. And finally, we can pass form data. We can pass object data through that form data field. Responses are returned by the server Oh, sorry about that. There should be another T in there. Rather than be embarrassed about it, I'm just going to call it out. Anyway, the server returns a response that has a status code that indicates what happened numerically. We're going to look at those in a second. The body of the response includes the requested data or details about what just happened. And the headers describe the response in terms of what's the format of it, what's the text encoding, etc. So we're going to look at these a little more in depth. When we're looking at URLs, the URL helps us tell the server what we want. We start in any case with an API base. So this is the base URL to the service we want. I just made one up, tacos.jk/API. And it's going to have a list. If you look at the documentation for this API, here are all the resources we provide. We have cat videos, dog videos, crawly thing videos. Within an individual type of thing, there's also probably a variety of endpoints to expose different ways of getting that data. So we may want a collection. I want all the cat videos. We may want an individual cat video. We know the ID for this. So we're going to say, give me cat video, whatever this ID is. We may also want to be able to query the server and say, we want all the cat videos that have a type of adorable. And this is all information that the API documentation is going to give you. What we're going to see later, however, is that a lot of this can be wrapped away and you don't have to deal with it with the different frameworks that work with popular services. We use this concept of CRUD to say, what are the kinds of things that we want to do with a resource? We have a unique thing on the server. We want to do something with it. What are the kinds of things we want to do with it? So CRUD is an acronym for create, read, update, delete. I've also seen Wikipedia list some alternate forms of this concept. Bread, I think they think that's cool. That's a food. It's easy to remember. Browse, read, edit, add, delete. They also, interestingly enough, list crap, which is create, retrieve, alter, and purge. But in any case, the important thing here is that all the things that we want to do to the data map to an HTTP method. And so how we specify what we want to do to the URL, to the resource that we identify with the URL, is by using an HTTP method. Post, get, put, delete are our main HTTP methods. Headers configure the requests. So one of the ones that we'll probably have in our headers all the time is we want to have JSON back. So our header includes accept application JSON. We'll see some examples of authentication info passed in there. And finally, if we're creating an object, our requests have the ability to send data as well. We want to create this object. Here's the object's data. It's serialized into bytes. So while it may be in Python a dictionary of values, it has to get converted into a string and encoded into bytes before it gets transferred. That's some Python 3 fun stuff for you. If you think you understand Unicode, you're going to have a good time. The responses that we get back are structured in a way that always have some things that we can get data out of as well. Status codes. So we look at the first digit, which identifies the class of response, and it maps to different kinds of codes, from errors to success messages. The ones we're going to see most commonly are these 9. And to help you learn these perhaps meaningless numbers more quickly, I've created the Nicolas Cage status code mnemonic. So let's look at the most common status codes. Status 200, okay. You just ask for something, here it is, everybody's happy. That's the one you want to see most of the time. Status 201, created. It's Raising Arizona. He didn't actually create a baby, he just stole one. But if you create an object, it's the status code you're going to get back. Great, that's what I wanted. Strange 204, no content. What no content really means usually is you just updated something. To update that something, you had to push that data to the server. The server says, you know what, you just sent me this. I don't need to send it back to you because you already have it. So no content. That's a good thing. However, we get into the 400s and we get 400 bad requests. 400 bad requests usually means you're doing it wrong. And you need to fix something about your request that's just poorly formed. We have 401, unauthorized. You haven't authenticated. Something went wrong with your authentication. And 401 responses are usually going to give you, in your headers, some idea of, hey, you're doing the authentication wrong. Here's how you're supposed to do it. Or here's a status about why you did it wrong, what's not working. Similar but different is 403, forbidden. You've authenticated to the service, but you don't actually have permission to that endpoint or to do the action that you want to do. So you may be able to get a particular resource, but you may not be able to delete that resource. 404, not found. You're asking for something that doesn't exist. Chances are really good that you've actually just malformed your URL. 409, conflict. Something is wrong. You're probably trying to manipulate data in a way that conflicts with data that's already on the server. And finally, one you really don't want to see, 500, internal server error. Who knows what's going on? So there we go. Response body is usually the data that you're requesting or some status about what you've just done. And we talked briefly, but when we talk about serialization, deserialization, it's a way of getting data to go over the internet in a string form and then turned into a native Python data type. So for JSON, it's going to end up being dictionaries and lists. And for XML, we're probably going to represent it as element tree tags. Let's make some actual requests. For all these examples, we're going to use a fictitious SAL server, the monkey reporting tool. We're going to use this URL, which is saying, I want to get a machine with this serial number. That's how SAL identifies it in its API. We're going to use the get method because we're trying to get that record. And SAL uses an authentication mechanism where you pass a private key, public key pair through your headers. All right, so we're going to do this first with curl just because it makes sense. Most people have seen curl. There's lots of examples about curl. It's a tool that you should have in your tool belt for working in the terminal. And it's pretty simple. We add the headers individually as a key value pair with a colon in between them, and we specify the URL last. Strangely enough, this is what we get back. And I've indented it and made it a little more readable, but 301, that wasn't one of our Nicolas Cage status code mnemonics, so I added one more. Redirected. I have a proxy in front of this SAL server, and so curl by default goes to the proxy server, and the proxy server says, okay, I'm going to redirect you here, and it just gives up. So we need to add in location. It's the full form. You can also do -L. Now we get something back. Okay, but this is not super readable. I'm on the wrong display. Here's my mousey. Great. That's not helpful at all. So final thing is we can pipe it. There's about 80 different ways to do this, but we can pipe it really simply. We already have Python 3 on there. So if we add on this last Python 3, pump it through the JSON tool, we can get nicely indented output. Now, it's colorized because it's been run through get pitches syntax highlighting. So don't get too excited, but here's the whole record. Briefly, I just wanted to mention, if you're not super familiar with curl, you may want to try out this guy. I'm not sure how they want you to pronounce it. I say HTTPy because I like pie. It has a pretty simple interface, but one of the things that it does that's really cool is from the command line you can make requests, and this is exactly what you get back. So it uses colorization in the output, as long as you don't have some kind of crazy, X term from 20 years ago. and it indents all the responses. It gives you all the headers. It can be a really helpful tool for just debugging and playing around with these things. So it makes it super easy. They have this example that I copied in here from their website where they post, they're creating a GitHub comment. It's really easy to do right from the command line. So check that out if you're looking for a command line client. But really what we're talking about here today is Python, as they say in the Isles, in the kingdom. So we're going to start just looking briefly at what you can do with URLlib, which is the standard library, a way to make HTTP requests. We're going to import some things here at the beginning, including urllib.request, which is how we're going to make a request. Like all these examples, we're going to create our headers dictionary, and we're going to make a request. So we create a request object, we pass the headers to that request. It hasn't actually been requested yet. So this is one of the multi-step things about URLlib that makes it a little more tedious to work with. And finally, we do URL open with that request object. We pass it an SSL context, which we'll be talking about later. You get your result, which you then have to parse through JSON. It's somewhat tedious. So finally, we come to the solution to this problem, which is Python requests. Kenneth Wright's wonder project, HTTP for humans. URLs at the bottom. There's a little description that they have on their website that's perhaps a bit flamboyant and exciting, but I think it's well earned. And it's worth pointing out that if you look at the documentation for Python's URLlib, right at the top it says, the requests package is recommended for a higher level HTTP client interface. So it seems to me like, while it's not in the standard library, and it almost certainly never will be, Python's maintainers say, go ahead and use it. Don't be afraid of using the Python package index. Get requests. How do you get it? It's that simple. All right. So for this example, request doesn't make our procedure of getting that computer object from cell significantly easier, but as we'll see later, it makes some of the other tasks a lot easier. So like the many others, we first import our tool for making HTTP requests. I skipped over the headers, but the headers part is exactly the same. And we say, okay, let's requests.get. Here's our URL. Here's the SSL certificate to verify against because this pretend Sal server has a self-signed certificate. Here's headers. Sal does a great, or request does a great thing where it can automatically convert your response into JSON without having to import JSON and do the JSON method to do so. So looking at constructing a request and a response, via requests, we have those 4 things that make up a request and those things that make up a response. To make a request with requests, we specify the HTTP method that we want to use by calling a method on the requests package itself. So get, put, post, delete, options, patch, whichever one you intend on using. The URL is the first parameter to the method that you're calling. So you put that right in. Oh, I have my mouse over there. Headers are an optional parameter to method. So if you're going to do a request.get, you can optionally add in that keyword argument. Headers equals headers. What it does in the background is it doesn't, just for that request. It says, okay, I'm going to add these headers in just for this request. But what we'll see later is that we have something interesting with requests called a session, where we can add those headers one time, and it's going to reuse them for the entire life of the session. So we don't have to constantly, whenever we make a request, put that headers parameter in. Form data passed in is also super easy. So if we're going to create a new taco on our fictitious website, tacos.net, we have to post to the tacos endpoint ID 0. It's a pretty common pattern for creating objects on a REST API. And it's as simple as just passing data as a parameter. Again, it's optional keyword argument. When we get a response back from requests takes the response from the raw HTTP response and wraps it in their own class and gives you this object back, this response object. And it has a number of properties on it that give us access to those things that comprise the response. So status code is a property. Headers are a property that are a dictionary, not just text. The body is available in multiple forms. This is the data that we're trying to get in the first place. If we want the raw bytes, we can say response.content. Okay, this is just raw byte objects. If you're familiar with Python 3, that makes a lot of sense. Response.text is the Unicode. For most of what we're looking at here, we're going to use JSON. That's the format that we get back. We can just call this JSON method. You'll notice I gave the brackets or the brace parentheses, hello, there, because you have to call it, unlike the other ones, which are properties. Finally, again, if you're super familiar with curl, here's a URL that's a pretty cool web app that allows you to paste your curl command that you know works correctly, and it'll give you the equivalent version in Python requests. We have to talk about SSL, the modern internet. Every single thing that we're going to do, that we're going to want to do, except for little toy projects that we set up ourselves, are going to be SSL. Currently, the Python 3 that I have on my machine is 3.6.1. Maybe that's not the newest one, but it ships its own OpenSSL with it. And you can install the certify package, which is a curated list of root certificates for verifying secure HTTP very easily through the installer itself. It creates a clickable bash script that runs the pip install to get this, and it sets it all up for you. Provided the information there just to kind of kick Apple's older Python OpenSSL while it's down. I don't know, is this NDA? Don't look at that bottom line. Requests takes the approach that, you know, in this day and age, it's 2017, we need to help the consumer of this tool, in this case requests, do the right thing. So they make it really easy to use best practices. They make it more work to do the wrong thing. And when we're talking about SSL, that means verifying traffic. If you get an HTTPS response and you're not verifying by the certificate that is used to encrypt it, that traffic is intact, it hasn't been messed with, then you're a bad person. Here's what this looks like. If I do a request and I have my certify package set up as recommended, as made super easy to do, and I make a request to an HTTPS site like pypi.org, the Python packaging index, I get the response back and it's happy. Nothing crazy happens. As far as you're concerned, nothing happened interesting. You didn't have to specify anything on the GET request at all. It just handles it behind the scenes. Meanwhile, let's say I'm going to get something from my internal site that has a self-signed certificate. Exactly the same way, I just provide the URL. I get an SSL error traceback because the certificate verification has failed. That self-signed certificate, there's no signing certificate in my trust chain anywhere that can verify it. So we can work around that. We can export the public certificate for that service into a PEM file and provide that to requests.get to the verify parameter. Although we probably should just go get a legitimate certificate from Let's Encrypt. If money is the problem here, they're free. They're already, Let's Encrypt as a root certificate is trusted by the certify package. You can work around all this and join the modern era. I probably shouldn't have even shown this, but this is what you shouldn't do. So you see a lot of suggestions on Stack Overflow and, you know, just make it work suggestions that you turn verify off by providing the false, and it just doesn't even look. If you're doing this, you're probably doing it wrong. Don't do that. So we get to sessions. This is kind of the last feature that we need to talk about, requests, that's super cool. But if you're doing a lot of stuff, so for example, I frequently would go and hit my, when I was a Casper admin, go and get all the data about all the computers. And that takes a really long time. A session allows you to use connection pooling, and it can significantly improve the speed of that. It also allows you to do things like put the verification certificate. So if this was a self-signed certificate for this service, I can add it to the session, and then I don't have to provide that every single time I call. It can make your code a lot cleaner, a lot more concise. You set up your connection to the server once, and then you never have to deal with it again. Likewise, you can set up authentication once and not have to deal with it. Headers, not to deal with it. Quick example, here I am making 3 requests to the same site. None of those requests have any optional parameters that we set up at the beginning. And if we look in the response, we can see that all of them use the stuff that we configured at the beginning. So sessions are sweet. We'll use them over and over again. And a lot of the wrappers that we're going to look at soon handle that for you. They automatically set it up for you, especially when you're dealing with OAuth. And so the final piece of getting to the fun part of this is how do you deal with authentication? So if you're trying to access a REST API of some kind, Twitter, Instagram, Spotify, whatever, they're probably not going to let just anybody like, woohoo, let's go for it. Let's give them whatever they want. Let's let them create whatever they want. Probably not. There's some kind of authentication scheme. So the most basic form of this is that when you do a requests.get or put or any other method, you provide some kind of auth as that authentication parameter. So basic authentication is really simple. We create a 2-tuple of username password. I assume it can also be a list, although I'm not sure for that. But you pass that to the session auth, sucks it in, and it uses that forever. Basic authentication is done. It's also not great, and you won't probably see this in a lot of production sites. This is actually short form syntactic sugar, as they call it, for not having to instantiate a basic authentication object and pass it along to the auth. What? Don't even worry about it. It's just pass a tuple, and you're really happy. It's very simple. We do a lot of examples in this presentation with Sal, and Sal uses this header method. So we've already seen this before where we have to add the headers to the session. The session headers are a dictionary, so we actually use the update method on it to say, okay, here are all these keys. If they're already in there, update them with these values. If they're not already in there, just add them in. So token authentication we've already seen. Probably most of the interesting big sites that we want to get data out of that have APIs are going to use some form of OAuth. There's OAuth 1, OAuth 2, and it's a pretty deep subject. If you look at Twitter's developer API documentation, there's a huge section on authentication. Fortunately, this has all been abstracted away, so we don't have to deal with it. And I'm super glad because it's confusing and I don't want to have to deal with it personally. So to do this, I had to go to Twitter's developer site and create an app. And they give me some tokens as a result. So most cases, if you just Google developer and whatever service you're looking at, you can go right to that site. You can sign in with your existing user account. There's not like a cost for that or anything. Oh, that's right, I have this thing. And you can start creating apps. So we're going to do a little example of this. I'm going to import this extra package, the requests OAuth lib, that gives me an OAuth 1 session. So it's wrapping the request session. It's going to handle all the authentication stuff for me, so I don't have to learn every tedious detail about how Twitter does its authentication. We're also going to import, just for funsies, Clarify app. This is another REST API. So we're going to be double dipping into the REST two-fisted API requests here. It's a image manipulation and what am I trying to think? Machine learning library. So the way we authenticate to Twitter is we provide a big bucket load of tokens to it. Because this is a super simple example, this is doing it on behalf of me, the developer. We're not requesting, we're not going through the workflow of you could create an app that anybody could log into that app, grant their permission for that app. You've probably seen this before. You know, Twitter requests permission to access your, here's the privileges that it asks, then it redirects you to the app, and then that thing can do things like create tweets on your behalf. We're not doing that for this example. We'll do that later for Spotify. So we create an OAuth session, which again is just a really glorified requests wrapper, a session wrapper. And now we can say, just like with requests, okay, I want to get this URL. And we're going to say, okay, we're going to hit the tweets endpoint, and we're using a query string to say we want taco tweets, and we only want images. Again, I'm going to hand wave a lot of this stuff away, but I've created a taco identification model with Clarify by feeding it all these pictures of tacos that I've collected over the years and saying, these are tacos. Learn about them.
This is like hot dog, not hot dog.
Well, you know, I learned about that recently and was like, well, that kind of steals my thunder. I feel naive for not knowing about that because I like tacos more. And anyway, too late. We can identify the tacos really simply. The Clarify app wraps all their API calls very simply. And so we just say, okay, model predict by the URL that we get out of the Twitter response. It prints out some chance percentages. We see that one of these images is 99.92% definitely a taco. Here's the responses that we got. Interestingly enough, I did not feed it enough images of real tacos, so it has identified the crispy tacos correctly, but the real tacos are more likely, I think it gives them like a 6% chance. These other things are definitely not tacos, though.
I can see why I thought that bottom right thing was a taco.
Yeah. Well, I think it gives it like a 0.1%, so this is just all the responses. But the point here is that I don't know the math behind machine learning and image identification. That's like way outside of my scope. But it took me, I think, like 30 minutes the other day while we were waiting for Yoan to get the server cluster up for us to do the workshop for me to add on the machine learning parts of this. So these libraries make it super easy to do these sorts of things quickly, without knowing too much. Like they make it very abstract for you to quickly do things. I don't think we need to beat JSON handling anymore because the great thing about JSON is, and the reason why it's used by a lot of these services, is that once you deserialize it, it's just native Python data types. You don't have to worry about it. So there's some examples here of using that, but it really just vanishes once you do it. And like I said, requests response object has a method which will just give you the JSON. In a lot of cases, you don't even have to deal with deserializing it yourself. Likewise, just an example of how to parse it, how to pretty print it. It's one of the nice things about JSON. If you do have a JSON imported, you can pretty print it and do all the indentation, but we don't need to worry about that in great detail. I don't want to talk about XML too much, but I feel like we have to a little bit. XML is radically different and more of a pain in the butt to deal with. And we're going to skip through this relatively quickly, but the main way of handling this with a standard library is with element tree. And we can add in LXML, which is a PyPI package that makes it a lot easier to deal with. It can be a lot faster, and it can do pretty printing for us. So looking at the time here, I want to skip ahead, but what do I have? When we get our responses, they're pretty ugly. There we go. So this is meaningless. This is not helpful for me. I'm an artist. I'm experimenting with this data. It's super useless. So we have to be able to pretty print that to be able to work with it. And there's a number of methods that are shown here, how to pretty print that. If you really want to copy that code in, you don't need to solve this problem yourself. Here's the code to do it. It's in the project. You can Stack Overflow that. But I think this is a good place to skip it, because what I am seeing is that the only place I have to deal with XML lately is in plist files and mobile configuration files, and it's kind of a subset of XML, or the Casper API. And that's handled. You don't have to worry about that. I also wanted to talk about web scraping briefly, because it's kind of parallel dimension to REST APIs. So we can just get a web page and we can manipulate it in a lot of the same ways. So we have LXML again, that allows us to parse the web pages and manipulate them in a way that works exactly like elementary. But I like to use Beautiful Soup for, and so just a quick example of what we can do with web scraping. There's this website, Speed Demos Archive. It's a curated Nintendo speedrun site. People try and run these classic games as fast as they can, and they time it from when you get control of a character until when you lose control, when you've beaten the game. And there's all different categories. For some reason, I thought Bad Dudes was especially ridiculous. I like the description, which says, it's a thoughtful introspective on the journey to find oneself. The games weren't super deep on plot back in the day, but we use Beautiful Soup and requests to get that game list on the Speed Demos archive. So it's just a simple request to that web page, and then we create a soup object by running it through Beautiful Soup. We can find all the list items in it and pull out the text. So it makes it easy for us to print out, here's all the games that are listed on that site. And I took it one step further and got all the Nintendo games ever released from Wikipedia using a similar method. We used Beautiful Soup again to parse that out. And then we used another project. I don't know anything about fuzzy text searching. There's all different algorithms for solving this, but we can import Fuzzy Wuzzy and it'll just do it for us. Yeah. So we take the Fuzzy Wuzzy and we categorize all these. And then I can say, you know, the names of these games aren't listed the same exactly on Wikipedia as they are on Speed Demos Archive. It's very simple for me to fix that by using Fuzzy Wuzzy to try and match those things with a high probability of matching. And then it's really simple for me to say, I want to take all games, I want to take out the games that people have speedrun records for on this. Here are all the games that I could potentially play and be a world champion on. Bugs Bunny Birthday Blowout, Sesame Street 1, 2, 3. You'll notice cool games mostly not on here. And of course, this isn't authoritative because there's other sources of records. But I wanted to briefly mention Selenium as a final tool to keep in mind. So Selenium allows you to script an actual web browser. There's different drivers depending on what flavor of browser you like to use, but it allows you to do things like execute JavaScript that you can't do just by using requests to get a page. So it'll actually run it just like a browser. If you're using one of the browser drivers, you can actually see the browser window and click in it and interact with it in the Python interpreter. So let's look at some examples very quickly of using some of these frameworks that Python provides for some of our services. We're going to look at these really quick, but most of these services, if not all of them that you want to deal with, have an API wrapper that makes it a lot easier. You don't have to form the URLs yourself. So first one I want to talk about is Spotify. I have this project called Actually Random, where I have this giant playlist of total bangers that I want to listen to when I'm out running. And Spotify doesn't remember what I've listened to. So if I run 2 days in a row, I'm probably going to have to hear, you know, the same song 2 days in a row. Even though there's 600 tracks, I somehow always manage to hear the same tracks. Do I want to have to figure out, by reading all the documentation for Spotify, how to form the URLs to do this task? Not so much. So the Spotify wrapper allows me to do some interesting things very quickly and very cleanly. The overview of this is that it's a Flask web app. So we're doing OAuth authentication to Spotify, and we're doing it in a way that it's granting access to a user's stuff. So we use OAuth 2 to authenticate a user and grant the permission to Actually Random to do stuff. Then we get that user's playlists and we display them. User chooses a playlist that they want to randomize, and it gets all the tracks from that playlist and shuffles them, shows you the results, and then you can save it as a new playlist. And then you just play that in order, and you don't have to deal with Spotify's crappy randomization algorithm. So to do this is super easy. Spotify, you import, it's a couple lines. You give it your access token as the developer, and it handles all the back and forth OAuth dance with the client and redirects you back into your app. Again, you can see the code for how exactly that works, but it's the less interesting part. We get a Spotify session object, and that allows us to get things like which user just authenticated, which playlists they have, And then we build some data just for display of the playlist IDs, names, and pictures, and this is what it displays. We're using Bootstrap within Flask to create this display. So say I want to reshuffle one of these, and these are not my giant banger list, but these are pretty short. So somebody selects a playlist, it then goes and gets all the tracks, and interestingly enough, Spotify limits the number of results you can get. So if I say, I want to get this playlist that's got 600 tracks, what are all the tracks in it? Well, you can only get 100 tracks at a time, and it does that to minimize the traffic to it. So this is kind of an advanced concept in dealing with REST APIs, but fortunately, Spotify makes it super easy by giving me a next method that allows me to page through the results. And I know Sal has just added this as well, so it's super useful and pertinent to my job. So I get all the tracks. We create a new playlist with the name that the person provided in the form. Spotify, again, abstracts this and makes it super easy. We just say spotify.userPlaylist create, and then the user ID and the name of the playlist we want to create. We don't have to manipulate URLs. We don't have to do anything else. It handles all that for us. And then it populates the tracks. So what you're interested in seeing is the actual graphics. It's not all terminal all the time for this guy. I have beautiful pictures sometimes. So this is only an 8-track playlist, but shuffled, save it as a new one. Everyone's happy. It can run faster. Similar example, I'm not even going to look at the code for this, but Strava is a social site. Maybe not everyone's as familiar with that, but it allows you to compete with your friends who run or bike. My friend Ken rides a lot, and so this is a third-party tool that somebody created using a developer API. It's free to use, and Strava has hired this guy as a result. But it takes all of my friend Ken's rides, and it says, okay, how many total miles have you ridden over the years? Apparently 10,708. It does some interesting things like calculating the total distance that he's gone, and displays it like, oh, that's like riding from Auckland to Oslo. So it's fun. It's an interesting way to visualize the data. Our next example, Google image search doesn't exist anymore, so you have to use Google custom search engine, but you can do any kind of search on Google with it. This example, we're going to create a triptych. So triptych's 3 images that are related to each other and displayed together. We're going to use the dictionary on the Mac itself to get some random search terms. We're going to randomly search Google images, and we're going to randomly select from results and process those into a result. So I've written a quick Google image search class that wraps that. Again, it abstracts away the need to deal with individual URLs, can handle the authentication. There's documentation in the READMEs. But the actual image search itself is very simple. You just say, I want to do a search. Here's my query string. I want a photo. I don't want raster or line drawings or anything. And I want size large. So here's one example of the random outputs and another. And of course, there's lots of weird things you can do with this, like using hot tweet topics or whatever else to populate these. We're getting down to it. Let's keep going. One of the things that's super interesting is you may have an API that doesn't have a wrapper around it. So Spotify makes it super easy to deal with Spotify, but what if you have a service that doesn't have one written already? And I'm going to look just quickly at Slumber, which is what I kind of consider to be the best of these. It allows me to create a wrapper around an API very quickly. So Sal doesn't have a wrapper to do API requests. But I can quickly wrap it. I give it the base URL of Sal. And then it does some magic behind the scenes using the getAttr magic method in Python to allow me to construct the URLs just by using method or dot notation. So in the second line here, I'm saying sal.machines. Here's my serial number. It breaks that down, takes the base URL, adds the machines endpoint, adds the ID, in this case serial number, and then get finally says, hey, send this request. I want it. It makes it super easy. I can get all the machines now that I've wrapped it. Sal.machines.get. This is a lot easier than our example earlier where we're having to manually create the URL and join pieces of the URL together. I mean, you know, taking over the world. It's broken as of now because, like I said, Sal returns paged results, so it wouldn't quite be this direct. But you can get the individual machine, like we showed in the description, and it also makes it super easy to create new things. So if I wanted to create a business unit in Sal, I create the dictionary describing that business unit, and the only requirements, as listed in the API page for Sal, is that you just need a dictionary with one key of name, and it's the taco consumption unit. So again, we create that new object very simply by just using that wrapped Slumber object, sal.businessunits.post. We provide the data that we want to post up, and it creates the object for us, gives us a response, which is its new ID. The final thing we're going to talk about is creating your own REST API. And again, we're trying to cover this stuff super fast to give you an idea of what's possible and what kind of tools you might want to look at to do it. It's obviously not comprehensive about how to do this. And this is not a Python project, but I have a wonderful intern working for me. His computer science skills are vastly greater than mine, and he's like always giving me crap about all these fantastic JavaScript projects and Node projects. So Loopback is a Node project. He provided me with some example screenshots of what it takes to set up a quick REST API. So like many Node projects that like to rub it in Python people's faces, they've got fancy Braille spinners for progress. They've got amazing interactive menuing and colors, and it's pretty ridiculous. But he's setting up a new application, so it's a command line utility that just walks you through setting up an API. We're going to use Mongo. He's super into MongoDB for his backend, and we're going to create a Taco API. So it walks you through making a model. How do you want to expose the data in that Mongo database? So we're going to create a Taco model. For simple purposes, we're going to create a couple properties on that model, which are the type of shell you have, the type of protein that's in it, and you call Node in the project, and it runs that server, and you've got a REST API. Now the cool thing is, now you've got interactive documentation of your API. You didn't have to make any of this. It's all automated for you. It creates all the endpoints automatically. And if you look at this, it looks awfully familiar to some commercial API documentation projects like Swagger, which I saw this and was like, wow, this looks pretty much exactly like Swagger. It looks pretty much exactly like the Casper API documentation, which I believe is Swagger. And I'm pretty sure Loopback is an IBM project. I'm probably getting that wrong, but one of the cool things we can do about this is not only do we get all the automatic documentation of this API, but we can interact with it and we can play with it. And so he created a screenshot for me here where he's just making a new taco entry in the database, just enters it in manually, and it shows all the responses and everything else. So definitely super easy, especially if you're just playing around. I couldn't let that go, so the new hotness in the Python world for creating REST APIs is called API Star. This guy, Tom Christie, also maintains a very popular API tool that can be used with Django, but he wanted to start with something that he could start from the ground up and ignore all of the problems with Django that he was seeing. So API Star is similarly easy to set up. You can create a new API Star API with a single line, and it initializes all the stuff, creates a project folder. I just took the example from their website and started following it and manipulating it quickly to take the data that we got from the Nintendo games list on Wikipedia to turn that into a REST API really quickly. So this is just boilerplate. It was all in the project that was created for me when I ran that initialization thing. I didn't have to write most of this. What we do have to do is attach routes. So we have to say, we want to have these endpoints. We want to allow these HTTP methods for that endpoint, and when we connect it to a method. And so I just implemented a couple really quick. I turned the Wikipedia entry into a SQLite database, and I didn't even do SQL Alchemy. I don't know why, because I hate doing SQL. Really, it's horrible, but we just create a couple quick functions, and all they do is do a SQL query and return the results. And a lot of the handling of that is done by API Star. So I do the result and I return it as JSON. API star handles all the conversion and serialization and stuff for me. I want to show what it looks like, and then we'll have some Q&A. So you just run it. You can obviously containerize this or run it in a more formal way, but just on my own laptop I can run it and then make a request using the same method we've used for all these other things. I haven't done any authentication on this because it's just running on my computer. I'm going to go to my local computer server and hit the games endpoint and print my results, and I get all of those games in JSON format. So of course you've played Xenophobe and Xevious. I can do a request for a single game by ID, then the Intergalactic Ninja, another classic. And we can also do things like queries. So I want to see, where's my mouse? I want to see all the games where the title has Mario in it. And of course I get a list of all the games. It's just some of the results from that. It too does the automatic creation of documentation. And if you've ever had to write documentation for an API, I've done a little bit of writing it for the SAL API, and I don't want to ever have to do that again. So this is way slicker. And if you see on the right-hand side, one of the cool things that API Star does that I haven't really played around with is that it has this core API CLI module that you can download. You can pip install it. And when you do that, and you pass it the schema for your API Star project, it automatically creates a Python module that is a wrapper around your API. So you don't have to deal with Slumber. You don't have to create your own wrapper. It just does it for you. And you can access it in this way that's kind of emerging to be the way to handle this, where you use dot notation to navigate through the hierarchy of resources. Finally, again, it does the interactive querying and in the documentation page. I have a couple other examples, but I'm going to skip them because I've talked about them before. So the code is in here for just yet another Flask or another API that you can create using Flask. Lots of people love Flask. It's a wonderful web framework. It's very lightweight. I used it to create a monkey client manifest service. And if you're interested in that sort of thing, the code's in here, and it's very easy to manipulate for your own needs. So I think we have some time for questions, which is a first for my presentations. So let's turn this on. Thing. It is on? Okay. I'm not going to do that. We'll just see what happens. But nobody has any questions because they all want coffee, and my coffee is cold. Crickets. I mean, if you want to. I mean, you're free to go. We've got 2 minutes left, but don't feel like you have to.
I actually do have a question.
Oh,
Yes.
don't feel like you have to stay just to hear this question, but I bet it's really good.
So, can anybody hear me? It's not on, actually.
They're
And I
trying
don't-
to save the batteries. He'll repeat the question. It's okay.
Yeah, I'll repeat the question. I gotcha.
Okay. So, in using the requests library,
Mhm.
I've been using it to query a Meraki database or
Mhm.
Meraki endpoints. It goes super slow, so I've heard a little bit about using AIO HTTP.
We've been playing around with it. We're actually doing our Mac health
AIO
reporting.
HTTP, that's the question?
Oh, yeah. He's asking about using requests. So, doing requests in a serial manner, one after another, versus using some of the Python 3 features that allow us to do asynchronous requests. So there's an AIO HTTP. Kenneth Wrights himself has written, was it requests async module a few years ago that I think it dumps out to G event to do it. So we've definitely investigated this, and we've also looked at hosting our own service using Sanic the Hedgehog. I think it's called, or it's named after Sanic the Hedgehog. It's an asynchronous web server. And I've definitely seen people say that, you don't necessarily at that level of the protocol need async. I've seen people say that it's taken a set of requests that take 10 minutes and make it take 30 seconds. And I've also seen, like, in most cases, that's probably because you're doing it wrong. I hate it when people tell me that. But I guess the frequency with which I hear it means that I'm doing it wrong in life. But I think there's possibly something to that. But request itself, I know that one of their big projects moving forward is to rewrite it in such a way that you can have a separate subpackage of it that does the Python 3 await concurrency stuff. So you can already do it with some of those packages. It's worth experimenting with. But also in a lot of cases, what I need to do, there's no time component where I'm like sitting around tapping my foot. And you can also cache a lot of that data. You know, you can use if it's a well-designed API, you can see if things have changed before you download the whole, object one thing at a time. So sometimes you're forced by the architecture of the API to have to get all the data all the time. Like I've had to do that with Casper. But other times maybe there's a way that you can do it where you can see like what's the hash of this or has it changed recently, and I can just keep it cached. Yeah. I mean if you look at the response headers, they will tell you whether you should consider whether you can cache it or not. I mean, you can cache it whether you want or not anyway, but most APIs will tell you like here's the data when you requested it. It's real for this one discrete moment in time, but possibly you may be able to last longer. You may have an endpoint in some of these more developed APIs, especially ones that are using these commercial API tools to create their API. Will have an endpoint that allows you to see, has it changed since the last time I've checked. I can save myself a whole lot of bandwidth by just saying, oh, it hasn't changed. We're going to use the copy that we've got cached locally wherever it is. Yes, I've worried about that quite a bit. Other questions? Lunchtime. Is it lunchtime?